So let's look at the first problem. The first problem is to find the 6 trigonometric functions of the angle theta. And you're given this triangle. And so if we wanted to, we could find cosine right off the bat, right? I don't know what sine is yet, but I certainly know that cosine is 7/8. And we can find everything else pretty easily. But to find everything else, we need to find that third side of the triangle. So we're going to use the Pythagorean theorem. 7 squared plus x squared equals 8 squared. X squared is going to equal 64 minus 49, and that's 15. And so x is going to be the square root of 15, or radical 15 if you prefer. So then we can see that sine of theta, and I need to, sorry, let me just move something here so I always end up covering up the chat like a fool. So let me not cover up the chat. I'll still be able to see everything. Great, cool, okay. So sine of theta would be opposite of hypotenuse, which is root 15 over 8. Tangent of theta would be root 15 over 7, opposite over adjacent. And then the reciprocals would be the reciprocals. So cosecant of theta would be 8 over root 15. It is okay if you don't rationalize these. Oh, no, that's not true. I said please rationalize the problem. So please do rationalize them. Although if you don't, you probably won't get knocked very much, if at all. But to rationalize, we just multiply by the square root of 15 over the square root of 15 and get 8 root 15 over 15. I don't think you need to show this work specifically, but you certainly can. Cosine, or sorry, the reciprocal of cosine is secant of theta. That's going to be the reciprocal of that, which is just 8 over 7. No need to rationalize there because the denominator is already a rational number. It's not irrational like that. And cotangent of theta is going to be 7 over the square root of 15, which is equal to 7 root 15 over 15. That's it. Also, I should point out, just like the quizzes, you're certainly welcome to print out the exam if you want to and write on it. You're also welcome to just write on your own paper. Just try to be as neat and orderly as possible to make it easier for me to find your answers. And I'm just going to keep going. So again, stop me if you have questions. Problem 2. Find all 6 trig values of alpha equal to 11 pi over 6. And mark the approximate location of the angle. Great. So let's do that part first. So we want to show where the angle is. We know a couple of things just by seeing it's 11 pi over 6. We already know the reference angle is pi over 6. Right? We are 1 pi over 6 away from either pi or 2 pi. Specifically from 2 pi. Right? 11 pi over 6 plus pi over 6 is equal to 12 pi over 6, which is 2 pi. So we know we're over in the 4th quadrant because we're really, really close to 2 pi. So that angle is 11 pi over 6. And just for the sake of writing it down, here's the reference angle, which is pi over 6. So then we want to find every trig function of this angle. And so what I'm going to do is I'm going to use the reference angle of pi over 6. I'm going to draw my pi over 6 triangle, or whatever way you want to remember it. I know that for this 30, 60, 90 triangle, the side over here is 1 because it's opposite the smallest angle. Pi over 6 is the 30-degree angle, smallest. Hypotenuse is 2, this side is root 3. And I know since my angle is in quadrant 4, sine and tangent will be negative, cosine will be positive. So when I try and find sine of alpha, it's going to be opposite over hypotenuse, but it's going to be negative because we're in quadrant 4. We're going to try and find cosine of alpha. It's going to be adjacent of hypotenuse. It's going to be positive because we're in quadrant 4. And tangent of alpha is going to be opposite over adjacent, which is 1 over root 3, which I'm going to rationalize as root 3 over 3. But it's going to be negative, again, because we're in quadrant 4. And then we do the reciprocals. Cosecant of alpha is going to be negative 2. Secant of alpha is going to be positive 2 over root 3, which is equal to positive 2 root 3 over 3. And cotangent of alpha is going to be negative root 3 over 1, which is just root 3. Those of you that joined us a little bit late, we're just going over the practice midterm. You can totally find it in Canvas under the modules and look at it and follow along, or you don't have to look at it at all. You can just watch me do it. And again, please chime in if you have questions. So be smart and erase the other side. I will also again reiterate, solutions of this are posted on Canvas. You can also look at the solutions. I don't think there's any errors, but if you ever think there's an error on something, or that I'm making an error in person, like I do sometimes, please let me know. I'm happy to correct it. I won't be offended if you say I'm doing something wrong, whether or not I'm actually doing it wrong, but I'm very realistic in that way. So question 3, if tangent of theta is equal to negative 4/3, and we know that sine of theta is positive. Notice, I want to point out, notice how the problem actually doesn't say those words. The problem doesn't say sine of theta is positive. It says sine of theta is greater than 0. But that would really encourage you to all hear it that way in your head, right? When you see sine of theta is greater than 0, you're like, oh yeah, that means sine of theta is positive. Or if sine of theta is less than 0, that means sine of theta is negative. It's a good thing to think about. We're being asked to find cosine of theta. And so we should be able to already jump to the conclusion. If sine of theta is positive and tangent's negative, we can't be in a quadrant where cosine is positive, right? We have to be in a quadrant where cosine is negative, because we can't be in quadrant 1 because not everything's positive. And we can't be in quadrant 4 where cosine is positive because sine is negative. You can also actually just find the quadrant, right? We know that we can't be here because tangent's negative. We can't be here because tangent's negative. We can't be here because sine is positive. We have to be here, which means cosine is going to be negative. So I already know, before I do anything else, that my answer is going to be negative something. I don't know what yet, because I haven't drawn the triangle, but I know it's going to be negative something. So now I'm going to draw the triangle. I know that tangent is opposite over adjacent, so I'm going to make the opposite side 4 and the adjacent side 3. And I guess if you wanted to be super precise about things, if you're really wondering where the negative sign would go, it would go on the adjacent side, because the triangle would really be up in the second quadrant over here. And this would be a -3 and a +4. You know me, you know I'm not worried about that negative, because I'm thinking about the quadrant I'm going to be in to find the answer anyway. But if you really, really, really wanted to, you could do it that way. I'm going to do it this way and say, okay, well, let's find the third side. I know you know it's going to be 5, but I'm still going to show the work. 3 squared plus 4 squared equals x squared. 9 plus 16 is 25, so 25 equals x squared. X is 5. I just want to point out, it's only a 3, 4, 5 triangle if the long side is 5. Right? Sometimes people will try and be sneaky. I don't do this usually, but sometimes people might be like, okay, you've got 4 and a 5 here, and then someone will be like, oh, it's a 3 over there. No, you know it's not a 3. The hypotenuse is the longest side. So just use common sense when you think about that. Don't get fooled accidentally by thinking you have a 3, 4, 5 triangle when you really don't. If you're ever not sure, just do it the long way. Right? Write out the Pythagorean theorem and make sure the hypotenuse side is the side that's by itself. and the two leg sides of the sides that are added together. So cosine of theta should be the adjacent over the hypotenuse, which is going to be 3/5. But we know it's going to be negative because theta is in quadrant 2. So there's our answer. Since tangent is sine over, oh yeah. Tangent sine over cosine. If we divide sine by cosine, will we get negative? Well, we should, right? That's an excellent point. So since tangent is sine divided by cosine, like someone wrote me, if we divide sine by cosine, will we get negative 4/3? And the answer is yes. Right? If we do sine of theta, which we actually don't know, but if we find it, like sine of theta should be positive 4/5, then sine of theta divided by cosine of theta should indeed be 4/5 divided by negative 3/5, which is 4/5 times negative 5/3. The 5's cancel and you get negative 4/3. Like you should. You don't need to do any of that work to get the answer to this particular question, but yes, since tangent is negative, sine divided by cosine should equal, or sorry, since tangent is sine divided by cosine, sine divided by cosine should end up equaling negative 4/3. Thursday. Someday, when we have more time, I'll tell you guys about anchor days and my birthday, but that's not today. So another day. It's really neat. At least I think it's really neat, which means it's maybe kind of neat. Let's look at the next problem. Let me turn up the AC in here. It's a little warm. Today, the smoke is not as bad as it was yesterday, but it's still not great. So the following question, number 4. Simplify the following to a single trigonometric term. We have tangent of theta times secant of theta minus sine of theta times tangent of theta. And my go-to kind of number one thing I do when I'm trying to simplify something down to one single trigonometric term is I usually try writing things in terms of sines and cosines, first of all. So I'm going to write all of anything that's not sine or cosine, so tangent, secant, cotangent, cosecant, as what it is in terms of sine and cosine. So tangent of theta, just like what someone pointed out to me in the message, is sine of theta divided by cosine of theta. And secant of theta is the reciprocal of cosine of theta. So it's 1 over cosine of theta. Sine of theta is sine of theta. And tangent of theta is, again, sine of theta divided by cosine of theta. And then I would do some simplifying. So let's see. So I'm just going to leave this out here. I could distribute that, but I don't think it's the right thing to do that. What I'm going to do instead is I'm going to simplify what's inside the parentheses. So it's probably worth noting that that's sine over 1. So that this part here is sine squared theta over cosine theta. So I have a 1 over cosine theta minus sine squared theta over cosine theta. And I'm kind of lucky because I already have a common denominator. So I can just put those two fractions together, or I can subtract them from each other to get sine theta over cosine theta times this stuff here, which is going to be the single fraction 1 minus sine squared theta over cosine of theta. Now, 1 minus sine squared is a trig identity we should recognize. 1 minus sine squared theta is equal to cosine squared theta. So this part here, we're going to replace this part here with cosine squared theta. So I have sine theta over cosine theta times cosine squared theta over cosine theta. And then cosine squared divided by cosine, one of those cosines cancels and one of those cosines cancels. And then cosine divided by cosine, the other cosine cancels and the other cosine cancels. That's equal to sine of theta. Yeah, you could probably show slightly less work there, but it's probably not a terrible amount of work to show. And I will also mention there's probably other ways to do this. This is just the way that seems the most natural to me. But if you do it a different way that's still correct, then it's really, really fine. All right. Let's look at the next one. I feel like this board's going on. Yeah. All right, cool. The next one being another simplifying problem. Cosecant minus cotangent. Cosecant of theta minus cotangent of theta times 1 plus cosine of theta. And I'm not sure. I might just FOIL this one out first. So I might just do this times this, which is cosecant of theta. And then this times this, which is cosecant times cotangent. And then this times this, which is minus cotangent theta times 1. And then this times this, which is minus cotangent theta times cosine theta. And now is probably the time to use the sine and cosine equivalence. So cosecant theta is 1 over sine of theta. Cosecant of theta is again 1 over sine of theta. And cotangent theta is cosine theta over sine of theta. Oh, okay. And then cotangent theta is cosine theta over sine theta. And cotangent theta times cosine theta is going to be cosine theta over sine theta times cosine theta. Okay. Yeah, that looks kind of weird. I'm not going to lie. What I would probably do at this stage is I'd probably get a common denominator. So I see that this term here has a sine squared as a denominator, and everything else has a sine, and a sine. So I probably, how do you combine the cosecant and cosine? So that's an excellent question because I made a mistake. And it's funny too, because I was thinking to myself, so I was thinking as I was doing this, you really have to be careful when you're writing these things out so you don't accidentally change like a cotangent to a cosine. Because cotangent and cosine both start with a CO. And I did exactly that. When I did cosecant times cosine, I somehow wrote cosecant times cotangent. So I blew it is what I did. That should be a cosecant times cosine, which means this should be a 1 over sine times cosine, which seems a lot more. I was like, this seems like it's really going to go badly because I made a mistake. Now we see that this cosine over sine and this minus cosine over sine, those are going to cancel out, which is a lot better. So then we've got 1 over sine of theta minus cosine times cosine is cosine squared theta over sine of theta. And now we can put them together. A good call. Thank you for the catch there. It's really funny how you can be thinking, oh, I shouldn't make this mistake, and then make the exact mistake you're thinking you shouldn't make. And then 1 minus cosine squared is sine squared. Sine squared theta divided by sine of theta is just sine of theta. So again, a word of warning. Obviously, you need to be careful with your work. It's very, very easy to make a small error. I will also mention, right, I definitely looked at this exam. There aren't any errors on it. I can be sure of that. And what I will say is things are meant to work out well. Right? There's no like real tricks. Things are going to simplify in a natural way. So something seems like it's going in kind of a super wonky direction. Take a step back and be like, oh, I might have made an error somewhere before that. Like this problem that I was just doing, right? When I had 1 over sine times cosine over sine, I was like, this looks like it's just not going to simplify very well. And that's the point where I should have been like, oh, maybe I've done something wrong. Like maybe I should try simplifying it a little bit more, like see if it goes somewhere. I probably would have done the common denominator, but like, this looks like just kind of wrong. So then I would have looked back and hopefully eventually seen, oh yeah, that thing that was that I wrote as cotangent really should have been cosine. Can I explain one more time what cancels? Sure thing. So these are canceling because they're it's the same thing, right? This is, all right, let me just erase here real quick. I'll write it again, don't worry. So this here is 1 over sine theta. Then I have cosine over sine, which you could write as tangent, minus cosine over sine. And a thing minus the same thing, those cancel each other out. It's like 5 minus 5, it's 0. And then this is minus cosine times cosine, which is cosine squared, over sine times 1, which is sine of theta. And then we can put this together as one fraction, and it ends up being in the denominator sine of theta. And in the numerator, we get 1 minus cosine squared theta, which becomes sine squared theta. And then sine times sine divided by sine is just sine. I'm canceling a sign there and a sign there. So hopefully that clarifies what's happening. You're welcome, anytime. All right, so moving on to problem 5. Here's 5A. Sorry. Find and simplify sine of 5 pi over 12. And I even give some very kind of detailed instructions by noting that, I said 5 pi over 12 is equal to pi over 6 plus pi over 4. Or as you might, in a first step, see 5 pi over 12 is equal to 2 pi over 12 plus 3 pi over 12. And again, right, when you're doing this, you're trying to look for fractions that add up to what you're starting with that reduce. 2 pi over 12 reduces to pi over 6, 3 pi over 12 reduces to pi over 4. And then we're just going to use the formula, which is indeed given. Sine of pi over 6 plus pi over 4 is equal to sine of the first angle times cosine of the second angle. And for sine, if it's a plus here, it's a plus here. And then it's going to be cosine of the first angle times sine of the second angle. This one's nice in that all of the angles are in quadrant 1. Pi over 4 and pi over 6 are both angles that are between 0 and pi over 2. So all of the values for sine and cosine are going to give you positive things. Meaning we know sine of pi over 6 is going to be positive 1/2. Cosine of pi over 4 is going to be positive root 2 over 2. Cosine of pi over 6, well, since sine of pi over 6 is 1/2, we have that cosine of pi over 6 is the other value, root 3 over 2. And sine of pi over 4, just like cosine of pi over 4, is going to be root 2 over 2. And then we simplify. 1 times root 2 is root 2. 2 times 2 is 4. Root 3 times root 2 is root 6. And 2 times 2 is 4. And then we can combine this in one fraction where you get root 2 plus root 6 all over 4. Or if you prefer, root 6 plus root 2. It does not matter which way you write. They're both correct. I usually default to writing the positive one first if there's a positive term and a negative term, but they're both positive here, so it really, either way is fine. The next one is not broken down for us. So the next one asks us to find cosine of 17 pi over 12. And they give us the cosine formula. It's going to be that cosine of something plus something is equal to cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. So we're looking for two angles, right? Alpha and beta, or A and B, whatever you want to call them. That add up to 17 pi over 12 that we know how to deal with. So I'm going to just look for the lowest hanging fruit. I'm going to say, okay, 17 pi over 12. I can't do pi over 12 because that doesn't reduce, but I could try 2 pi over 12 plus 15 pi over 12. And oh yeah, both of those reduce. That's going to be pi over 6 plus divide both top and bottom by 3. You get 5 pi over 4. This is not the only option, right? You could make a different choice. You could say it's going to be 3 pi over 12 plus 14 pi over 12. And that reduces to pi over 4 plus 7 pi over 6. And I think there's probably one more option that would also work. I would pick one of these two options, where one of your angles is for sure in the first quadrant. So you don't have to think about if it's going to be positive or negative when you take sine or cosine. So it doesn't really matter which one you pick. Let's go ahead and pick this first one. So I'm going to do cosine of pi over 6 plus 5 pi over 4. And that's going to equal cosine of pi over 6 times cosine of 5 pi over 4 minus sine of pi over 6 times sine of 5 pi over 4. I know pi over 6 is in quadrant 1. And yeah, definitely, you would definitely get the same answer even if you choose a different option. It might look like it's in a slightly different order. In fact, I'll just show you. I'll do the other option as well. So this one's going to be, let's see, cosine of pi over 6 is going to be root 3 over 2. And cosine of 5 pi over 4 is going to be, well, 5 pi over 4 is in quadrant 3. We know a pi over 4 angle has a value of root 2 over 2. So cosine of 5 pi over 4 is going to be a negative root 2 over 2. And sine of pi over 5 pi over 4 is going to be the same thing. Sine of 5 pi over 4 is also going to be a negative root 2 over 2. Because we know the value is also root 2 over 2. And we know since it's in quadrant 3, it's also going to be where sine is negative. And then sine of pi over 6 is going to be 1/2. And then we'd simplify. We would have root 3 times root 2 is root 6 over 4, but it's negative. And then a negative times a negative is going to be a positive. So it's going to be plus 1 times root 2 is root 2 over 2 times 2 is 4. And so you could write this answer as either negative root 6 plus root 2 all over 4, or you could write it in the way I would choose to write it, which is root 2 minus root 6 all over 4. That would also be perfectly fine. And I'm giving myself not enough room here. I'll just write it up here. So if we did it the other way, right, if we chose to use instead cosine of what was it, pi over 4 plus 7 pi over 6, cosine of pi over 4 times cosine of 7 pi over 6 minus, right, if the plus for cosine, it's a minus in the formula, and then it's going to be sine of pi over 4 times sine of 7 pi over 6. Okay. Interesting. Sorry, so
I have a question.
yeah.
I was looking, you know, the cosine, the pi over 6.
Uh-huh.
Since it's I'm not sure if we look at the quadrant when we're doing cosine pi over 6, or like, for example, do we look at the initial quadrant, like how
So
pi over 12?
typically for angles that are small, like pi over 6, pi over 3, and pi over 4, I don't usually think about the quadrant because I know it's in quadrant 1, and I know that everything is going to be positive in quadrant 1.
But what about like cosine like 7 pi over 6?
So that's going to be negative because 7 pi over 6 is in quadrant 3.
So you have to look at each of them individually and not like cosine of 17 pi over 12, like that's in the quadrant 3. We don't look at it like that.
Yeah, so we don't. So that's an excellent point. I'm not looking all
Okay.
for the quadrant of the original angle. I'm looking at the quadrants of the angles I know. Now, I will point out, since you bring it up, 17 pi over 12 is in the third quadrant, which means our overall answer should be negative because it's cosine of an angle in quadrant 3. And our overall answer is negative. It's a number minus a bigger number, which is negative, all over 4. So but again, you don't need, for this kind of problem, you really don't need to think about what quadrant the original angle is in. You only need to think about what quadrants these angles are in.
Okay, thank you.
You're welcome. I'm just checking something for myself real quick. That's right. No, there's just something that usually happens with this kind of problem that didn't happen with this particular example that is atypical for me, but it's totally right. So we're going to get cosine of pi over 4 is root 2 over 2. Cosine of 7 pi over 6 is going to be negative root 3 over 2 because it's in quadrant 3, but the reference angle is still pi over 6, so it's going to have a value of root 3 over 2 minus sine of pi over 4, which is again root 2 over 2, and sine of 7 pi over 6 is going to be negative 1/2. And hopefully everybody can see that we've got the same thing, right? I've got a negative root 6 over 4 here, and I've got a positive root 2 over 4 here, which is exactly what I had here, which is the same answer. So any way you break it down, as long as it's correct, should get you to the same answer. Right, let's look at the next one. Given that the sine of theta equals 3/4, and cosine of theta is negative, find the following. Sine of 2 theta. So sine of 2 theta, we're going to use the double angle formula, which is 2 sine theta, cosine theta. We already know sine theta, but we need to know cosine theta. So we're going to draw ourselves a little triangle. Sine is the opposite over the hypotenuse. This third side, x squared plus 3 squared plus 4 squared. So x squared plus 9 equals 16. X squared equals 16 minus 9, which is 7. So x is the square root of 7. So then sine of 2 theta is going to equal 2 times sine of theta, which is 3/4, times cosine of theta, which is negative, because they told us it was negative, root 7 over 4. And we can multiply this out. It's going to be, I would probably cancel a 2 here and a 2 here. So I'd have 3 times negative root 7, or negative 3 root 7, all over 2 times 4, which is 8. Or if you didn't simplify it first, you'd end up with negative 6 root 7 over 16. But then the 6 over 16 reduces to 3 over 8. For cosine of 2 theta, we end up getting cosine squared theta minus sine squared theta. That's the version of the formula I prefer to use. And then we're going to get cosine, which is negative root 7 over 4, quantity squared, minus sine, which is 3/4. That's going to be positive 7/16, right? Negative 7 squared is 7, 4 squared is 16. And this is going to be 9/16. We subtract, we get negative 2/16, which is negative 1/8. And if you've done things correctly, sine of your angle and cosine of your angle should end up having the same denominator. That's pretty much a tried and true fact when you're doing problems like this. And then since sine is negative and cosine is also negative, we know that the angle 2 theta is in quadrant 3. Because quadrant 3 is the quadrant where both sine and cosine are negative. That's our justification. Our angle is in quadrant 3 because sine of the angle is negative and cosine of the angle is also negative. Okay, move on. So for the sake of time, I'm going to skip 7a. I'm going to do 7b though. They're virtually the same, so I don't think doing both of them is really super necessary. Let's do 7b, which is cosine of 7 pi over 8. And we're going to use the half angle formula to find this. And so the half angle formula is given. It's the one we need to use is the one for cosine. It says cosine of theta is plus or minus the square root of 1 plus cosine of 2 theta all over 2. If it was sine instead, it would be plus or minus the square root of 1 minus cosine of 2 theta all over 2, which is also given. So I'm just going to replace the angle theta with 7 pi over 8. So cosine of 7 pi over 8 is equal to plus or minus the square root of 1 plus cosine of 2 times 7 pi over 8 over 2. Okay, this is the problem. I don't remember who asked me. Someone asked, like, do we need to think about 17 pi over 12, which quadrant? And no. This is the problem where you have to think about what quadrant the angle is in. So 7 pi over 8 is really close to pi, but it's not quite there. So 7 pi over 8 is in quadrant 2. And if our angle is in quadrant 2, cosine of the angle has to be negative. So our answer is going to be the negative square root of whatever we've got here. Okay. So our answer is going to be negative square root of 1 plus cosine of 2 times 7 pi over 8 is 7 pi over 4. Cosine of 7 pi over 4 is going to be either positive root 2 over 2 or negative root 2 over 2. It just depends on what quadrant the angle is in. So this is going to be negative square root of 1 plus, let's see, 7 pi over 4 is in quadrant 4. So cosine of 7 pi over 4 is going to be positive root 2 over 2. All over 2. And if you didn't simplify this, you probably wouldn't miss very much credit. But I do want you to simplify as much as possible because it is fairly standard. So then we're going to multiply the insides by 2 over 2. We're going to get negative square root of 2 times 1 is 2. 2 times the square root of 2 over 2 is the square root of 2. And in the denominator, 2 times 2 is 4. And then we need to point out that that 4 in the denominator is still in the radical. But the square root of 4 is 2. So we can simplify this one step further, where the radical is just in the numerator. Radical 2 root 2, sorry, the radical of 2 plus root 2, all over just the square root of 4, which is 2. So this is how this kind of thing typically simplifies. If you didn't do all that, like if you were stressed for time on a test, I would say stop here before you write this. And then if you have time at the end, come back and finish this off. But like this part is not the most important thing. I mean, I suppose you could say that about a lot of this class. A lot of this stuff is not the most important thing. Like probably all of it is not the most important thing. Yes, obviously your classes are important. You want to do well in them, but I don't know what I'm saying. I'm just trying to say have some have perspective, right? Of course, we all want to do well in our classes, but it's also good to recognize that they are not the end all be all to what's going on. All right, so let's look at number 8. Write the equation of a cosine function with an amplitude of 3. So on cosine, we want an amplitude of 3. We want a reflection across the x-axis, or I'm going to say a vertical flip. And we want a period of pi. I guess I can write that down. Okay. So I'm going to start with y equal to cosine of something. What do I need to make the amplitude 3? I need a 3 out in front. What do I need to get the vertical flip? The minus sign out in front. And then to get a period of pi, well, I know there's going to be an x in there. And I know the period is equal to 2 pi divided by the coefficient of x. So what does the coefficient of x need to be so that this period is equal to pi? Exactly. The coefficient of x needs to be 2. There we go. That's the equation that we were asked to figure out, or that's the equation of a cosine function that has all those things. And so this question didn't have a vertical shift at all. But if there had been like a vertical shift of 1 up, we would add 1, or 2 down, we would subtract 2 at the very end. And then they asked us to graph it. So I'm taking a period of pi. I'm going to cut it up into 4 equal quarters, or 4 equal quadrants. So 1/4 of my period is pi divided by 4. So I've got the points 0, and then pi over 4, and then 2 pi over 4, which is pi over 2, and 3 pi over 4, and 4 pi over 4, which is pi. And then we know cosine would usually start at the top, and it would go top, middle, bottom, middle, top. But since it's got a vertical flip, it's going to flip over, and cosine is going to start down here, and then at the next point hit the middle, and then the top, and then back to the middle, and then back to the bottom. One thing that's nice to remember about trigonometric functions like sine and cosine that are periodic is if you're doing one full period of them, you should always end with the same y value that you start with, so that it can then start over again. This is going to look something like this. When you graph these things, your graphs do not have to be perfect. They just have to be pretty good. Meaning it shouldn't look like, so on some of you, I think either on your homework or the quiz, I made a comment that your graphs look really straight and they should look a little curvier. So try it, right? Like if it's like a straight line from there to there, it should look a little curvier. And the other kind of just feature I noted for a few people was that when you're, for cosine especially, like when you're getting to the bottom here, right? It can't go any lower than this like that. Some people want to like go down and then come back up. That point there has to be the bottom. So you can't you don't really want to overshoot it. Just like that there has to be the top. You don't want to go above it. Again, not things that are like, I'm not going to be like a super stickler for points on like, oh, you went a little below or a little above, but just trying to help you make sure your graphs look nice. Okay. Let's look at the next one. So I know we've only got 5 minutes left, but I think my plan is going to be, I'm going to go through the whole practice exam and just go over. If you need to go, you're welcome to leave. If you want to stay, you're welcome to stay. And then I will post the video of it. So if you had to go and you missed something that you wanted to see, you will be able to see it. Also, you can look at last year's video, which has, I think, pretty much the same examples and more slides as well. But please do feel free to stay and watch the whole thing, because I do think, I know the last part of the test that we haven't gotten to yet are kind of the things we've done most recently that you might have more questions about. So please stick around if you can. But again, you are certainly not required to if you cannot. Or even if you don't want to. You're just like, James, I know this stuff. I don't really need to be here. There's absolutely no requirement to stay after class is over in 4 minutes. So now we're graphing this one. I'm just going to write down some things. Amplitude is 2. Vertical shift is up 1. And the period is 2 pi divided by 2/3. And whenever you divide by a fraction, the thing you really want to do is just multiply by the reciprocal. That's 2 pi times 3/2, or 2 pi over 1 times 3/2. And you can either cancel those 2's and get 3 pi, or you can say, well, James, that's 6 pi divided by 2, which is 3 pi. Whatever way you get there is fine. And then I guess I'll draw my graph down here. 1/4 of my period is equal to 1/4 of 3 pi, which is 3 pi divided by 4. So drawing it, drawing it. As long as you can find it, and so mine does not look, these should be equally spaced out. Mine doesn't look perfect. It doesn't have to be perfect. Just try to do your best. So right, my first point is obviously 0. And then I'm going to add 3 pi over 4 to get 3 pi over 4. And I'm going to add another 3 pi over 4 to get 6 pi over 4, which reduces to 3 pi over 2. And then another 3 pi over 4 to get to 9 pi over 4. And then another 3 pi over 4 to get to 12 pi over 4, which is 3 pi. And then we're shifting up 1. So our new middle is up 1. And I definitely encourage everybody to draw this line, or at least think about where that line is when you have a vertical shift. And then our amplitude is 2, meaning we're going to be going 2 above our middle, and 1 plus 2 is 3, and 2 below our middle. 1 minus 2 is -1. And then sine starts in the middle, then goes up to the top, back to the middle. Be careful. I did see a number, not actually a ton of people, but a few people definitely did go, when they went down to the next point, they wanted to go down right there to the x-axis. But we need to go down to the bottom. And then back to the middle. Essentially, these 3 values, the top, the middle, and the bottom, which are 3, 1, and -1, are the only y values we should make note of when we are graphing this. There we go. Looks pretty okay. All right. There's actually not too much left to do. But I should say there's not too many problems left, but there might be some discussion around those ones, because I feel like this is where people have questions, which is really, really, really okay. So if you have questions, don't hesitate to ask them. I also do have office hours today at 3 o'clock, so you're certainly welcome to come and ask them there as well. So the first question 9, write out in words what the following means, and then say the answer. So inverse sine of √3/2. So in words, here's what this means. Inverse sine of √3/2 is the angle that, so the shortest way of writing this, I think, is the angle whose sine is the square root of 3 over 2. Or if you want to write more words, you say is the angle that if we take sine of that angle, we get root 3 over 2. And I'll just say, I don't think I said this to everybody. I will point out, it is in fact true that sine, well, if we don't write out that way, we write in function, that sine of inverse sine of root 3 over 2 is root 3 over 2. That's an angle. It's the angle that if you take sine of it, you get root 3 over 2. So if I take sine of this angle, it should equal root 3 over 2. Okay. So now here's the question that we need to answer. What's the angle? What angle do you take sine of and get root 3 over 2 is your answer? It's either pi over 6 or pi over 3. Which one is it? Might have to think about it. Yeah, it's pi over 3. Exactly. So theta is pi over 3. But really what I should be writing is inverse sine of root 3 over 2 is equal to pi over 3. But I do actually want to see some words like this, where you actually tell me what the meaning of inverse sine of root 3 over 2 is. Because I do agree that it can be challenging to understand this inverse trig function thing. It can be, I definitely remember struggling with a concept similar to this when I was learning it the first time a long time ago. But then it did take a lot of practice, I will not. But eventually, through repeated hitting my head against the wall, I eventually was like, oh yeah, okay, I kind of get this now. Let's look at the next one. The inverse cosine of negative root 3 over 2. And so again, I do also, oh, isn't it also, so excellent question. It isn't also 2 pi over 3. So you make a really good point. So the inverse sine is a function. And so I could have been, I don't need you to be this explicit on your exam, but I could have been more explicit right here and said it's the angle between negative pi over 2 and pi over 2, right? Because we defined, or really we let other people define, so okay, we agree that we're going to define this function to have outputs that are between negative pi over 2 and pi over 2. So that means 2 pi over 3 can't be the answer, because 2 pi over 3 is not between negative pi over 2 and pi over 2. And just to go one step further, I will point out that if you were solving a trigonometric equation, if I was asking you to solve sine of theta equal to root 3 over 2, then the answers would be pi over 3 and 2 pi over 3. Because when you're solving equations, it is perfectly fine and natural to get multiple solutions. But when you're evaluating a function, we are only permitted to get one output for each input. Yeah, excellent question. Thank you for bringing that up. I think that's a really good point. So inverse cosine of negative root 3 over 2, same idea, and I'm going to be a little bit more explicit here. So this is the angle. And again, I don't need you to write this next part on your test, but I'm going to write it for you now. Yeah, exactly. That's why it's called an inverse trig function, because one input gives you one output. Right? That's what we call it, a function. And that's what a function is, right? A function is always a thing that if you give one input, you get one output. I don't want to get too into it because we're getting ready for a test. It doesn't really revolve around that, but we can talk more about that later for sure, because it is an important idea. So inverse cosine of negative root 3 over 2 is the angle between 0 and pi. But again, I don't think you need to write that part. No problem. I'll post the video as soon as I can. So if you want to watch the rest of it, that you can. But yes, anyone that needs to go, welcome to go. So this is the angle whose cosine is equal to negative root 3. Okay. So what angle is that? What angle do we take cosine of and get negative root 3 over 2? That's a really, really good question. Why is cosine between 0 and pi and not pi over 2, negative pi over 2? And here's the answer. So if we look at the unit circle, here's 0, here's pi over 2, here's pi, here's 3 pi over 2. But really, I'm going to think of this as negative pi over 2. Right? I can go pi over 2 this way. I can go negative pi over 2 that way. So, and yes, that is totally the correct answer, 5 pi over 6. Cosine of 5 pi over 6 is equal to negative root 3 over 2. Cosine of pi over 6 is equal to positive root 3 over 2. So here's why the inverse cosine function isn't defined between negative pi over 2 to pi over 2. It would be lovely if it was, right? It would be super, super great if all of the inverse trig functions had an output that was between negative pi over 2 and pi over 2. The problem is inverse cosine of a negative number can't be an angle that's from 0 to negative pi over 2, because this is quadrant 4. And in quadrant 4, cosine of an angle in quadrant 4 is going to be positive. And so that's the problem, is if I want inverse cosine of a negative number, I have to end up with an angle that's in the quadrant where cosine would be negative, which is either quadrant 2 or quadrant 3. And we decided we're going to pick the quadrant that's next to quadrant 1. We can't pick quadrant 4 because it doesn't work. So we pick quadrant 2. So we go 0 to pi. So this quadrant, sorry, these two quadrants, 0 to pi, this is where inverse cosine lives. Right, the outputs for inverse cosine are anything from 0 to pi. 0 to pi over 2 if it's inverse cosine of a positive number, pi over 2 to pi if it's inverse cosine of a negative. In a similar way, this is where inverse sine and inverse tangent live. If you're taking inverse sine or inverse tangent of a positive number, you're going to get an angle in quadrant 1. If you take inverse sine or inverse tangent of a negative number, you're going to get that corresponding negative angle in quadrant 4. Let's say it was inverse sine of negative square root 3 over 2 instead of inverse cosine. Would the angle carry the negative as well? So it would. So yeah. So but the answer wouldn't be negative 5 pi over 3. The answer would be negative pi over 3. So the answer for inverse sine and inverse tangent is that it's much easier. You don't have to think about what's happening in quadrant 2. You're just like, oh, if I know the positive angle, I know the corresponding negative angle. So I would say, since inverse sine of root 3 over 2 is pi over 3, I automatically can just be like, oh yes, inverse sine of negative root 3 over 2 must be negative pi over 3. So for inverse sine and inverse tangent, it's super easy for the negatives. It's just the corresponding value for whatever the positive end is. But excellent question. All you guys are asking great questions. Good. I'm glad it makes more sense. All right. So let's look at problem 10 and 11. And yes, I know. So again, I know I've said this already, but if you want to go or need to go, you are certainly welcome to. I'm just going to finish this up because I think people who would like to see it will stick around. And if you want to see it later, it'll be posted. So let's look at number 10. Evaluate the following. Inverse sine of inverse cosine of negative 3/5. Okay. Before I do any drawing, let me ask you guys a question. I know I say this question, I never feel like this. What kind of thing is inverse cosine of negative 3/5? Well, I'm taking sine of it. It must be an angle that we call theta. And I want to ask, well, I'm asking about the answer to my own questions. What quadrants could this angle be in if I'm taking the inverse cosine to get it? It could be in quadrant 1 maybe, or it could also be in quadrant, is it quadrant 2 or is it quadrant 4? What quadrants are inverse cosine allowed to be in? Exactly, quadrant 1 or quadrant 2. This one's specifically going to be quadrant 2 because inverse cosine is negative. But what I really want to say is, whether it's quadrant 1 or quadrant 2, we know that sine of an angle in quadrant 1 or quadrant 2 has to be positive. So we know our answer is going to be positive. We'll also work it out, but I just want to say that. So let's draw the angle, which is they draw the triangle for the angle. Cosine of our angle should equal, so it's the angle such that cosine of the angle equals negative 3/5. That's the whole deal. And we're trying to find sine of this angle. So find the third side, it's clearly 4. And then sine of that angle is 4/5. And we know it's positive because inverse cosine of negative 3/5, this is in quadrant 2. Because that's where inverse cosine of negative things live. All right, let's look at the next one. Inverse, sorry, not inverse. Tangent. I did 2 inverse cosine ones. That seems irresponsible. I'm going to change it to inverse. No, I see why I did that. Okay, fine. Tangent of. I'm going to change it just to be more interesting. Tangent of inverse sine of the same number, negative root 33 over 7. I feel like this question gives more information. Same idea. This thing here is an angle. And I'm going to draw the angle. And what I know is that sine of that angle should equal this value. So I know the opposite side should be root 33. I don't really need the negative there, although you're welcome to write it if it makes you feel good. 7 there. And I need to find this third side so that I can find tangent. Tangent of this angle will end up being root 33 over x. We're going to find x. But actually, is it going to be positive or negative? Well, inverse sine of a negative spits out an angle in quadrant 4. Tangent of an angle in quadrant 4 is negative. So now we just have to find the third side. X squared plus the square root of 33 squared equals 7 squared. X squared plus 33 equals 49. X squared equals 49 minus 33 is 16. So x equals 4. So our answer is going to be negative root 33 over 4. And again, we know it's negative because inverse sine of a negative number gives you an angle in quadrant 4. And tangent of an angle in quadrant 4 has to be negative. All right, let's see what else have we got here. Okay, 4 more problems and then we'll call, oh, sorry, 3 more problems and we'll call it a day. Thank you for staying. I mean, not that you were required to, but I appreciate the attention. I'll try and wrap it up relatively quickly here. So the first one, so we're solving trig equations. And again, our angle is between, our answers are between 0 and 2 pi. So we have, first of all, 1 plus tangent of x equal to 0. We're going to isolate our trig function. We're going to get tangent of x equal to -1. You can either think of this as looking at the 45, 45, 90 triangle so that the angle is pi over 4. Or you can think about it as sine and cosine essentially being equal to each other because tangent is sine over cosine. But it has to be negative. So my thought process here really is I'm looking for where tangent of x equals +1. Because I know that the negative really just means a different quadrant, right? I don't really think about negative signs. I'm just like, okay, ignore that. Where is tangent equal to +1? Well, that's going to be where x is pi over 4. But that's not really my answer. That's really more my reference angle. So then the actual angles I need are the angles in the quadrants where tangent is negative. So tangent is negative in quadrant 2 and quadrant 4. Okay, so I'm looking for angles in quadrant 2 where the reference angle is pi over 4, and angle in quadrant 4 where the reference angle is pi over 4. Well, the one in quadrant 2 is 3 pi over 4, and the one in quadrant 4 is 7 pi over 4. Or if you prefer, this one is pi minus pi over 4, which is 3 pi over 4. And this one is 2 pi minus pi over 4, which is 7 pi over 4. So those are my answers. 3 pi over 4 in quadrant 2, and 7 pi over 4 in quadrant 4. If the question had been tangent of x equals to +1, the answer would have been the angles in quadrants 1 and 3, which would have been pi over 4 and 5 pi over 4. All right, 2 to go. No problem, Kristen. I will see you later. I'll also point out the exam, I guess, is available, but I would certainly make sure you're ready to take it before you take it. Got time. Next one is 4 sine squared x equal to 1. Again, we're going to isolate the trig function. So divide both sides by 4. Sine squared x equals 1/4. And then take the square root of both sides. Now, when you take the square root of both sides, you take the square root of both sides, you get sine of x equal to positive or negative the square root of 1/4, which is just positive or negative 1/2. And again, I'm going to think about where sine of x is equal to 1/2, which is a reference angle of pi over 6. So to get sine of x equal to positive 1/2, I want the angles with that reference angle in quadrants 1 and 2. So for sine x equal to 1/2, my answers are going to be pi over 6 in quadrant 1 and 5 pi over 6 in quadrant 2. For sine of x equal negative 1/2, which is also perfectly valid here, I want angles with this reference angle in quadrant 3, which is 7 pi over 6, and quadrant 4, which is 11 pi over 6. And that's it. One thing I'll say is that typically when you have a trig function squared all by itself, you end up getting that trig function equal to positive and negative number. You end up getting an answer in each of the 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Positive, positive, negative, negative. That's fairly typical. All right, let's look at the last one. Yeah, a little over. Thanks again for the time. I appreciate it. So let's look at the last one here. We're going to solve cosine squared of x plus cosine of x equal to 0. So I know I just said if you have a trig function squared, typically get answers in all 4 quadrants. That's really only true if it's the single trig function squared equal to a number. If you have trig function squared and then other instances of that trig function, all that goes out the window. When you have more than one instance of your trig function, we typically want to factor as much as possible. So I'm going to factor out a cosine from each of these. I'm left with a cosine there and a 1 there. This cosine times cosine is cosine squared, and cosine times 1 is cosine. And then we're going to set each of the factors equal to 0. Say cosine of x equal to 0, or cosine of x plus 1 equal to 0, which means cosine of x equals -1. And these are values for cosine that actually don't occur in any quadrant. These are values that occur at quadrantal angles. So we draw the unit circle with the 4 kind of points on it. Here at 0, we have the point 1, 0. Here at an angle of pi over 2, we have the point 0, 1. Here at an angle of pi, we have the point -1, 0. And at 3 pi over 2, we have 0, -1. So looking at cosine of x equal to 0, and again, cosine is the x coordinate or the first coordinate. What angles do we get where cosine is equal to 0? Well, I see one at the top of the circle. And I see one at the bottom of the circle. And then I also want the angles where cosine is equal to -1. And that's going to be over here on the left side of the circle. And those would be the answers to this equation. Right, that is the whole practice test. Minus like half a problem. I'm certainly happy to entertain any questions about it if you have them. And I'll keep recording for that moment. So does anyone have any questions they want to ask about the practice exam? Perfectly fine if you want to.
Just to make sure the midterm will only be 1 hour, right?
Well, so you're given 2.5 hours for it, but my intention would be that you don't have to spend that much time on it. You're being like in a normal in-person classroom setting, yeah, you'd have like 50 minutes, but these are different times you live in. I feel like giving more time is reasonable because people have different situations where it might be challenging to take things in. So yeah, you'll have 2.5 hours to do the whole thing, get started, print it out if you need to, write your answers, scan, upload, assign questions and stuff. All that should be very doable in the 2.5 hour time window. It's probably too much time, but it's fine. And yes, I can redo 4B, but let me ask anyone else. So good question. How do we determine if we get answers in each of the 4 quadrants? Basically, if you have a trig function like sine or cosine or tangent, and it ends up equaling a positive or a negative, that's when you say, well, I know sine is positive in quadrants 1 and 2, and it's negative in quadrants 3 and 4. So I can get answers in each of the 4 quadrants. Or for example, if we were being asked to solve something like cosine squared of x equal to 3/4, this is typically where it comes from, because this equation, cosine can be positive because a positive number is squared will equal 3/4. So you can either get cosine equal to positive √3/2, because positive √3/2 squared is 3/4. But you can also get cosine equal to negative √3/2, because negative √3/2 quantity squared will be positive 3/4. This is the kind of situation that leads to answers in all 4 quadrants. You too, Anthony. Right? Sorry. This is the kind of equation that leads to answers in all 4 quadrants, because you can have your trig function being positive, where this one would have answers in quadrants 1 and 4, and your trig function can be negative. This one would have answers in quadrants 2 and 3. So usually it stems from having trig function squared equal to a number. That's usually the beginning of a question where you have answers in all 4 quadrants.